Hey guys, we are looking at evaluating and solving nth roots. So the first thing we need to talk about is some common powers that we know. So taking things to the third power. So 2 to the third gives us 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. And 7 to the third is 343. So then we can also take things to the fourth power. 2 to the fourth would be 16. 3 to the fourth would be 81. 4 to the fourth would be 256. And 5 to the fourth would be 625. We can do 2 to the fifth would be 32. Anything much bigger than that, 3 to the fifth, that grows pretty quickly. So 2 to the sixth would be 64. You can fill in more of those if you want to, but those are just some common powers that we would use. So looking at our square root of n, we could rewrite that as n to the 1/2 power. The square root means n to the 1/2 power. So then the cubed root would be n to the 1/3 power. So if I take n to the 1/2 power and I square it, so n to the 1/2 is the square root. Remember we said square root and squaring, those are opposite things. And remember when you are dealing with your exponents that you have a power to a power, you multiply. So that would just give us n. The nth root of a, we can rewrite as a to the 1/n power. Just some terminology here. The number outside your radical is called your index. The number inside your radical is called your radicand. So index and radicand are two terms that you will want to know. So find the nth roots of a. So we have the fifth root of -32. So the fifth root of -32, or -32 to the 1/5 power, is -2. I guess it doesn't need parentheses there, but -2 is your answer. Then we have the third root of 64, and I'm getting these from our common powers page. So the third root of 64, we could rewrite as 64 to the 1/3. That's 4 times 4 times 4. That would be just 4. So rational exponents, a to the m over n. So m would be the power and n would be the root. So rewriting without radicals, just like we did on that last example, if I wanted to switch this over to an exponent, I have 16 would be my base. The 9 is the denominator. That index value is the denominator. And the 5 then would be the numerator. So 16 to the 5/9 power. So in general, if you want a statement here, it would be the nth root of a to the m. So here, if we want to change this over, this would be the 7th root of 10 to the 3rd. All right, so simplify without a calculator. So I could rewrite this if I want to as the 4th root of 81 to the 3rd power. Well, I definitely don't want to try to do 81 to the 3rd power. So I'm going to do the 4th root of 81 first. So what do I multiply 4 times to get to 81? Well, 3 times 3 times 3 times 3 or 3 to the 4th would give me 81. So now I have 3 is the 4th root of 81, still to the 3rd power, and 3 to the 3rd is 27. Then I have 16 to the 3 halves, or the square root of 16 to the 3rd. The square root of 16 is 4. 4 to the 3rd, 4 times 4 times 4 is 64. I have 64 to the negative 2/3 power. So 64 to the negative 2/3 power, I'm going to rewrite as the cube root of 64 to the negative 2. So the cube root of 64, 4 times 4 times 4, would give me 64 to the negative 2. So 1 over 4 to the 2nd then would be 1 over 16. This one I have the cube root of negative 64 squared. So the cube root of negative 64 would be negative 4. And then we square that, and that would give us a positive 16. So those are different answers there. All right, then I have 4 to the 5 halves power. So I have the square root of 4 to the 5th power. So the square root of 4 is 2 to the 5th power. 2 to the 5th is 32. And then here I have the 5th root of negative 32 to the negative 3. I always put that negative with the numerator so that you can worry about that later. So the 5th root of negative 32, well, since that's an odd, it's okay to have the negative. So what do I multiply 5 times? Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And I take that to the negative 3. So that's 1 over negative 2 to the positive 3. Well, negative 2 times negative 2 times negative 2 is negative 1 over 8 would be my answer. All right, evaluate with the calculator means just put this directly into your calculator. So try to plug it in, make sure you're using parentheses correctly, make sure you're getting the same values that I am. If you're not, let me know in class and we can go over how to plug this in so that you are getting those values. So I get negative 106.17 here. And then for B, I get about 6.85. If you want, you could have changed this to negative 123 and done caret key 2/5. If that's easier for you to write it like that. You also can go into math and use that button as to get the 5th root in there. All right, so solving equations. First you need to isolate the power, then take both sides to the reciprocal power, check for a square root. Is it even? If so, we need plus or minus. If it's odd, we don't have to include plus or minus, and then we simplify. So very much like when we had something squared, except we just have a larger power here. So the first thing I'm going to do is try to get this y to the 4th by itself. So I divide both sides by 5. So I have y to the 4th is equal to 16. Then I'm going to take the 4th root of both sides to get rid of that 4th power. So the 4th root of 16 is 2, but since it's even, I need plus or minus because I could plug in negative 2 as well. All right, in this case, a lot of you are going to try to multiply out y minus 1 times y minus 1 times y minus 1, and you'll end up with a big mess. But all we really need to do here is take the cube root of both sides. Now the cube root of 32 does not come out nice, but we get y minus 1 is equal to the cube root of 32. And then we're going to add 1 to both sides. So I get y equals 1 plus the cube root of 32. But I'm not going to leave it as that because there is a perfect cube that goes into 32. I know that the cube root of 8 comes out nice. And I know that 8 times 4 is 32. So I have 1 plus the cube root of 8, and the cube root of 8 is 2. And then I have the cube root of 4 that has to stay. So 1 plus 2 times the cube root of 4. Okay, that's all I have for you for today. So if you have any questions, feel free to come in and see me. Otherwise, I will see you in class.